choice we make, not something that just happens.
Good morning, everyone, and welcome to the Global AI Bootcamp 2019.
Thanks so much for joining us at over 125 different venues across the globe on December 14th to host these events.
This is a new paradigm shift. It's completely different from the classical traditional programming that we used to do for so many years. So the classical traditional programming requires what? Requires actually you, as a developer or a software engineer or a designer, to come up with certain business rules, and based on those business rules, you build a computer program which has all the logics already embedded in the logic of the code of your program. And when you apply this logic against the new input data, you come up with output, which is the desired output, whatever the desired output is. Machine learning is a completely different game. It's a paradigm shift, as I told you, because it doesn't start with identifying the logic up front. Instead, it actually takes two inputs. The first one is the data, which is historical data, and also takes into consideration the output, how the output behaved or looked like in the past. Then the machine learning itself, it builds association between the output and the input. And it comes up with the logic that you need to have in place. So in the future, if you have new data, unseen data, it will apply the same logic that it learned already from its data. So I don't need to be specific here when I come up with my logic here. I don't come up with a specific what-if scenario or what-if condition here. And instead, the machine learning algorithm will figure out the relationship between the output and the input and come up with the model which has already the rules that can be applicable to the future unseen data and apply the same logic. So to put some context here, assume that you need to build an application to identify or differentiate between the cat and dog based on the picture you take. So in the classical traditional programming, we have to come up with certain rules or attributes and define those attributes that define a cat and those attributes that define a dog. So, for example, the shape, the color, the face, the nose and mouth, etc. So you have to build that logic yourself and come up with very comprehensive, complex, nested if conditions to be able to differentiate between a cat and dog. This is the classical traditional programming. Machine learning is different. Machine learning actually what needs from you is I need a bunch of pictures. Just tell me this is the cat and bunch of other pictures. This is the dog. Feed that to the model, and the model itself will try to find the pattern that differentiates between the cat and dog, and come up with a model that in the future, when I feed the model with another picture, it will be able to differentiate between the cat and dog because already understood the hidden patterns already in among those pictures, and be able to identify the characteristic of the cat and dog based on the hidden pattern in the picture. So machine learning as we know today basically covers or answers 5 types of business questions. So far, I'm talking here about machine learning in particular when you go and build your model yourself. The first one is answer a very fundamental business question here. How many or how much this will be in the future? So when we talk about how many or how much in the future, we basically talk about regression. So it's a regression model that will help us actually to identify how the price of a particular item will look like in the future, based on understanding exactly the attributes that feeds or constructs the price of this particular element. So if we need to predict how much or how many, we talk about regression models. The second category is classification, which is this A, B, or C? This is just a basic classification model. So So in the example of the cat or dog, is it regression or classification? Classification. Then the third key questions here, machine learning can help us understand or answer is how the data is clustered. So how the data is organized actually, based on certain behaviors in the data without being explicitly labeled, without knowing exactly what this look like. But the machine learning itself will go and understand exactly the attributes amongst different areas in your data and try to cluster them or organize them into certain buckets. And this kind of machine learning, we call it unsupervised because we don't already have a label data. So we don't have a label data that tell us this is cat or dog. But instead, we can feed the model with so many pictures, and the model itself will try to see, okay, this could be a category of birds, or this could be a category of animals, or this could be a category of fish, for example. So it will find its way actually to categorize the data, then it's your responsibility later on to confirm the organization or the structure of the data based on the clustering algorithm. And the last question here we try to answer is anomaly detection. Is it weird behavior or not? Is it like outlier in our data, or this is normal behavior on the data, based again on the previous historical data that we have already in our system. So, back to Power BI. The spectrum, for those of you who didn't attend the morning session, this is the entire spectrum when we talk about either AI or automatic or machine learning in Power BI. We started from right to left, Azure, where you can build a complete model in Azure services. For those of you who attended Matthias' session, he was talking about how actually you build a model in Azure, then you can consume it wherever you want. So you build a model completely from scratch in Azure, then you can call it in Power BI. Or you can rely on the very complex pre-trained models that already Microsoft came up with, and they are considered cognitive services and just API. Those are complex models, pre-built already, pre-trained already. We just use them as a black box. Put them, you pass them input, you get output, and you interpret output the way you want. So those are anything that comes in Azure that either you build a model or you consume the cognitive services API. Then, as we move forward to the left, you can also build the your model completely from scratch within Power BI itself using Python and R code. This would require you two key skills here. You have to be a data science or understand actually the data science very well, and also understand the code. The R and Python code, because you will build a model from scratch, including actually testing the model, training the model, validating the model, evaluating models, identify the score. Then when you are comfortable with the results, you actually start to use this model in your Power BI. This requires what? Again, data science and requires coding. And you know that I told you up front I hate coding. So that's not my preference. If we move forward to the left side, then we will have the AutoML, which is the feature within Power BI that will allow us to build a model completely within Power BI without the need to write single line of code. Then AI, the services, the cognitive services that we covered in the morning here, it's again, like as you see, it's very easy, drag and drop. You just pass the column and it will tell you the key phrases or sentence analysis, etc. So there is no need actually to understand that you are delivering actually machine learning model. It's actually cognitive services built into it. So the focus for this session now is how to do things in a very self-service way without the need to understand data science or machine learning or coding within Power BI to answer questions or to build a model based on your own data, not to rely on the pre-trained model that Microsoft already created for us as an API. No, actually you will use your historical data to come up with your own model based on your historical data. So we'll train the model and build the model within Power BI. So the capabilities that we have from within Power BI itself now is we can do prediction, we can do classification, we can do regression, we can do forecasting, and anomaly detection as well as still in the review. So the key 5 questions that we covered before: how much is it A or B or C? How the data is clustered? What else? And anomaly detection. You can do all of those, answer all those questions from the AutoML capabilities within Power BI. So, option 1, write a Python code or R code. Option 2, you can actually do the machine learning in Azure. And there are 2 ways here: either to use Jupyter Notebook, build a model completely using Python R and Azure service, or you can actually leverage the drag and drop tool that is called Azure Machine Learning Studio, which is one step to help you reduce the time to write the code yourself. One step, but it has its own limitation as well. So let us go through this scenario. Assume that you need to, let us say that you're in a car or you work in a car rental industry, and you need to build a model to help you predict the demand of your car or particular car in the future. So imagine that you have inventory of cars and you have all the history, and you need to predict actually in the next month what will be the demand for each one of the types of your car. So we start with getting the data, which is the historical data, because this is always the starting point for us. You need to start with the historical data. Then you prepare the data. You need to come up with a model, train the model based on your historical data. You score and evaluate the model. You can try multiple models, actually, not just one model, because you can try actually multiple models and pick and choose which model has the best performance. How? Because we split the data between the training dataset and the testing dataset, and after you come up with the model based on the training dataset, you score that against the testing dataset, and the model that performs the better, it's a good candidate for you to start actually using it and deploying it. Then the final step here is actually the deployment of the candidate that you selected already as a best candidate based on your evaluation process. So this is actually the entire process that we go through to build the model. So Azure Machine Learning Studio is helping us reduce the time that we need to write the code, because it's a drag and drop tool. You start actually with, as you see here, you can get the data, so you drag and drop the data source, then you actually do any data manipulation that is needed, so you have another node here in your GUI structure, and identify exactly what needs to be done, and the data, eliminate records, or eliminate columns, or replace missing value, etc. Then, as you see here, there's another component here. You split the data, and you identify the threshold of splitting the data, so it's 30, 80-20, etc. After you split the data, you move to the train model. Then you pick which model that you are which algorithm that you want to choose actually to train your model. So in this case, 2-class logistic regression. Then you score the model. Then you actually start to deploy it and move forward with your deployment process. So as you see here, it's a drag and drop, easy to use, no need to write code. You just need for each node here to identify the inputs that needs to be considered here to be able to build a model, and also you choose the algorithm that you want based on the type of business challenge or business question that you are trying to answer. Is it regression, classification, forecast, etc. So there are so many algorithms that are readily available within the Azure Machine Learning Studio, and they are categorized here based on the business challenge or question that you are trying to answer. So for anomaly detection, we have a bunch of model algorithms here you can choose from. For classification, there are so many options here, whether it's a 2-class classification or multiple class classification. So is it yes or no, or is it A, B, C, D? So based on that, you have so many options here. You have clustering options, recommendation, regression, etc. So, and as you see here the other steps as very like this is a typical scenario. Import data, process the data, split the data based on the threshold, pick and choose which algorithm to those, train the model, score the model, and evaluate, and based on that you proceed with the selected model. So is it good? So easy, right? No need to write coded code. But in reality, it's not as simple as I showed in the previous example. Because in the reality is, remember I told you have so many options here? So which one to choose? Why do I need to choose this, not this one? In reality is, either you have like hardcore data science experience, but even though if you have this kind of experience, you still need to examine so many options here. And try each one of those options, and evaluate each one of those options, get the score of the evaluation, compare them, and get the best one. Also, for each one of those algorithms, there are parameters, set of parameters. And those parameters, they have impact on the result of the model itself. So the decision here that you need to make, even though it's a self-service drag and drop, but you still need to make some informed decisions down the road while you are doing the process here. You have to understand the algorithms, how it works, which category of the algorithms that you are going to use, and also evaluate multiple of them, and also play with the parameters for each one of those algorithms. And this is actually in reality how the model will look like, because you can actually, as you see here, there are multiple models were used actually to work on the same data set and evaluate each tool separately, get the best candidate, try another branch here, evaluate another two, get the best candidate, etc., etc. So you keep actually evaluating all those algorithms or those models actually down the road until you actually come up with the best candidate. So it can be a very, very time-consuming process, even though it's a drag and drop. So, as you see here, even though it's self-service, drag and drop, etc., but you still need to make so many decisions here, which requires skill set that the majority of us, or some of us at least, we don't have. First of all, it's a very repetitive mechanical process. And also requires some data science experience and the skills as I told you, but you still need to make also some manual decisions during this process. You need to actually manually split the data yourself. You need to choose which algorithm category that you want to choose based on what kind of business question that you are trying to answer, what kind of data that you are trying to predict. You choose algorithms to either high parameters, compare the models, deploy, etc. Then you finally consume the model. Remember we talked about automation and it's hitting everyone. So automation is even disrupting this process because this is can be a good candidate for automated process because it's a very mechanical, very repetitive, and this is exactly what AutoML is doing. It's going through all the multiple algorithms, so you don't have to have the intelligence or the experience to pick this, not this. No, AutoML doesn't matter. You scan all the algorithms, tune all the parameters, try all the parameters with all the combinations, go through this behind the scene, and it will give you the final result, and that's it. Some people they may like this approach, some people they disagree with this approach. You know, some data science they say that this is not the right way to do it, but this is how AutoML works as we have it today. So automated machine learning, AutoML automates features engineering, which is one of the very complex topics actually in data science for building a machine learning model. So it automates feature engineering, algorithms, and hyperparameter selections to find the best model for your based on your data, and they give you the best candidate track record. So I think we had the previous question about ensemble technique. My friend here asked about that. Yes, this is actually how it works. Again,
the question is, what about the framework selection?
Yeah.
Engine selection.
Yeah. So it uses ensemble techniques because this is actually it scans everything with all the parameters, with all the combinations, with all the algorithms.
Underlying like TensorFlow.
Yeah, I'm not sure, to be honest with you. I'm not, as I told you, I'm not a data science. I don't even care because The way I see it here, like the analogy that I like to say here, to be a good driver, you don't have to be a good mechanic. Those are two different skills in my opinion. Like, if you happen to be a driver but a good mechanic at the same time, that's good, that's bonus. If you have a problem in your car, you can go and fix it yourself. That's perfectly fine. But to be a good driver, you don't have to be a good mechanic. This is how I see auto-ML. I am a consumer, I'm not interested in how the agent works. I'm a business person, I'm a strategic business management consultant. This is actually what I focus on. The mechanics, I leave it to the mechanic guys. Maybe they are in better position actually to answer your question. So, yeah.
Sorry, it's the first time I hear of the ensemble learning technique. Can you explain it to people who not?
Again, it's the basic premise of that. It's actually what I just explained. It goes against all the algorithms, all the hyperparameter tuning, try all the combination, and come up with the best candidate.
Oh, okay.
It's like scanning everything. Like it's serious scan. But this will require high computing power because it's very time consuming as well.
So right in the cloud, or
it is in the cloud, yes. But again, you don't see visibility to that because this is actually automated ML is doing behind the scene of it. That's why it takes time, but you don't know exactly what is going behind the scene. I have a very good visual actually to segment you the process how it works.
Actually, I have one more question.
Yeah.
So, what about the batching kind of thing? Like, if you want to do a streaming kind of streaming models, can you do that?
Like live evaluation of live model. Yeah.
Rolling window kind of.
Yeah. Some applications, some use cases, they can do that, but some people they say no, we need to freeze the model during a certain period, and if we have to evaluate it, it doesn't have to be online, like retrain the model online.
Not exactly online, but rolling window. Like
It can, but this is not the AutoML. AutoML doesn't give you this kind of AutoML within Power BI. Sorry, I have to be very clear here because AutoML it does exist in two areas. AutoML exists in Power BI, which we have very limited control over, but also it does exist in Azure, which Matthias covered in his session. Then you have much more control than what we have in Power BI. The focus for this session is AutoML within Power BI. So, and the third option, as I said, you can use AutoML and the cloud services, then you can consume it wherever you want, but this will require you to have your Azure subscription. Here is the fun. Here is what I'm talking about here. This is how AutoML works in Power BI. So it takes you against like a weather. And as you see here, there are some steps here. Creating and training your model, improve it and apply it. It takes you through steps. Then it will give you the candidate, the selected candidate based on the performance. The areas that we cover so far is we have binary prediction, which is binary prediction is
Yes or no?
yes, exactly. Two class classification, yes or no. And general classification, which is multi-class classification yes, that's multi-class classification, and also we have regression. Regression when you need to predict a continuous number, like price, weather, etc. And then we have forecasting model as well. So those are so far the options that are really available within Power BI itself. Does it mean that Azure itself is limited to that? No, Azure has much more than that, but those are what we currently have within Power BI, but in the future, we may have some more options to actually choose from.
Just a quick question, what's the difference between regression and forecasting?
Forecasting, I think it's more focusing on the time series and takes that time series forecasting into consideration. So here is just like in a dynamic way, this is actually how it takes you through the steps. So you identify your output variable. It will actually pick and choose do artificial engineering. Will tell you those are good candidates actually to consider as an input of your model. Then you pass some additional information, boom, it will actually go on and does the magic behind the closed doors and give you the candidate actually that it believes is candidate. Also, it gives you a comprehensive report about the performance of the selected model as well.
Again, that's in premium, not pro.
That's premium. That's premium, not pro. For now. Okay, so let us see then. See how this works. So in our scenario, we will actually try to build a model to predict customer churn, which is a very common use case for any machine learning model. Is everyone aware of customer churn? So customer churn is basically, you work in a company and based on certain profile of your customers and et cetera, and the kind of services that they used to have in the past, and based on the transaction, et cetera, and at a certain point of time, those customers either stayed with your company or they left the company for whatever reason. So the scenario that we have here, this is a simple scenario for sure. Let us assume that we have just like very limited input variables that we need to consider to be able to predict whether this person will churn or not. This is just a very simple example. Like real life situation can be much more complex, but this is just to explain to you the concept. So we start actually with the historical data that we have, which is labeled data already because we know already this customer stayed or left the company. This is what we use for training our data. Then, what we really need to do, if we have in the future a new customer with this attributes, this age, which doesn't exist in our historical data, this income, which doesn't exist, or it could exist, but the combination of those two don't exist, or never existed in our historical data, the education level, gender. So we may have new data completely that is out of the scope of the historical data that we had already in the company, or the combination could be completely different. So how now to predict whether, based on what we know, assuming that we have the ability to predict based on those variables. So based on those factors, we need to predict whether this customer will churn or not. So this is actually like a binary classification model, it's a 2+ classification model, and the answer is either I need under yes or no. So what we really need to predict now is the churn. So in your understanding, do you think the AutoML will tell you whether this customer will churn or not? The answer, the technical answer is no. The technical answer, machine learning is all about the statistics, and it's all about mathematics. And there is no mathematical model will tell you yes or no. The mathematical model will give you the likelihood. Right? Likelihood. And the likelihood is up to you as a business to interpret this likelihood as whether this is, to me, I am willing to consider this as a potential churn, or no, forget it, I think this customer will stay. So the model will give you a number, likelihood. And it's a business decision now to say, okay, if I am 60% confidence this customer will churn, it's up to the business now to decide whether I need to treat this as a churn case or ignore it. Because the whole idea here, I'm talking from a business perspective now. I don't talk machine learning now. I'm talking about from a business perspective. Because what is the purpose of identifying whether this customer will churn or not? Why do I need to know upfront whether this customer will churn or not? Because I need to attract them. I need to do something extra for them to retain them for my company. Nothing is free. So if I flag this person as a potential churn, so I have to do something for them to attract them or retain them in my company. And this is cost associated with that. It's either to give them a promotion or a discount or whatever. Right? So there is cost associated here. So we have to be careful about this likelihood. There is no science behind it. It's a pure business decision now. So this is exactly how the model, the process that we will look like. We will have this unseen, it's a new data. We pass it to the model that was developed based on the historical data that we have. Then it will give you a probability here. there is 65% chance that this customer will churn. Now what do you do as a business decision maker? Do you want to treat him as a yes, he will leave, then I have to do something extra, or just ignore it and move to the next one, or raise the bar for a higher threshold here? Those are, again, no data science will be able to help you with that, with those kind of decisions. Those are business decisions, because there is cost associated with each one of those scenarios. We'll cover that in a second. Someone has a question.
That model that was that built by a business user or was that built by a data scientist?
The model is actually built completely by the automated machine learning process that I just explained earlier. So you push the data, the magic happens, they go across all the algorithms that I told you, try all the hyperparameters, etc., comes out with the model. Then in the future, you pass a new data that was not seen before based on the historical data, then the model will give you a likelihood. That's it. In non-auto ML scenario, you build the model yourself, of course, from everything from scratch. In the automated machine learning scenario, you rely on the automated machine learning process that in simple technique that I just explained, which is scanning everything, scoring everything, evaluating all the models, and giving you the result.
So the business user could just initiate all of that, right?
Exactly, and this is debatable too, because some data scientists, they don't like that, because they say that this is not the right way to do it, but whether they like it or not, it's coming no matter what. It's like the moving from manual car to automated car, for example. I'm sure at that time some mechanics didn't like the whole concept of automated car, and it will fail and it will not work, etc. So then it becomes evidence. Now we're moving to the autonomous car, actually, not even an automated car, it's an autonomous car now. So whether you like it, whether you disagree or agree with that, it's coming, it's hitting everyone, it will become reality, if not now, in the near future, for sure. Yeah, oh, so many questions. So can I finish, please? Because we haven't even started the demo yet, so let me finish the demo, maybe it will answer your question.
How do we know that this model is the best model?
Again, this is actually, trust me, it will be even much better than any, I will offend some of the data scientists here. To me, the data science as we do it today is data scientist dependent, not data science dependent. Why? Because we still rely heavily on the knowledge and the experience of the data scientists rather than the science. Because if you can give the business challenge to different data scientists, trust me, you will get two different answers and two different models. Why? Because it's still data scientist dependent, not the data science dependent. The data scientist as an individual plays very important role of the accuracy of the model.
That's what I'm saying.
Some people, they may disagree with that, but this is how I see it, how I understand it. Like, if my understanding is limited, that would be a completely different game. But the idea here of AutoML, it takes that bias out of the consideration completely and it tries everything. Why do I need to debate with you whether my algorithm is better than your algorithm or my parameters combination is different from your hyperparameter combination? Let us try all of them. Let us examine all of them.
Because behind the scene, you're trying all the models to see which model is the best model for us, right?
Yeah, that's why it's actually scanning all the models, trying all the hyperparameters and score all the models and pick the first one. So it takes the bias out of the discussions here. It's not about my model or your model or my algorithm or your algorithm. So let's rely on the science, let's rely on the machine. So let us do this quickly just to give you a sense of what I'm talking about here as a hands-on. So, starting point here is identify your data source. So this is actually a very big data set because I got it from Kangan actually. So it's a very common use case of telecom customer churn in the telecom industry. Just identify the source. So as you see here, there are so many gender, senior citizen or not, partner, they have dependencies, tenure, etc., etc. So there are all those dependent variables that we need to actually understand how they are impacting, or going to impact the churn flag as an output. So this is the historical data that we have here. So I'll just upload this. So the data now is being loaded actually to the cloud, so the data flow. Fresh now, just make sure that we have all the data loaded. Good. So now, as you see here, and the option here we have is the machine learning model. So it's taking me through a wizard now. Good start. Okay, here you go. Entity. I just pick the query that I just built. Then I have a list of all the columns that I have already in my data. So output field is the label. So it's telling me what you want to predict. Because you can technically predict any of those variables. Any of those variables can be used as, but is this important to the business or not? What if I give you all the parameters, then we can predict the age of this person, for example. Is it going to drive any business decision? Well, it is not. But what we really need to predict here is the churn. So I pick churn as output variable. So what you want me actually want to is it the yes or the no? Is it the churn is yes or no? Because this will actually help now creating the business meaningful report that will be generated here. So I'll just explain that this will be clear in a second. Actually. So we need to focus on the yes now. So the customer shared yes. We need to give meaningful label to that. So if the customer shared is yes, I want to call this sure. And if it is not yes, technically it is no, I want to call this state. This customer will stay. I'm trying now to put some business meaningful words that will be more meaningful when the business user actually read my report, not my report. The automatically generated.
There's a spelling error.
Excellent, sure.
No, so it doesn't matter because this is just a report. Okay. Remember when I picked the chair from the column, I was not given any other option but binary prediction. Why? Because again, this is the automated process that I just explained to you. Why do I need to bother the business people if the other models are not applicable to his or her scenario? So the column was detected as yes or no column, and as a result, the only selection or option that you have now is binary selection. Even though we have so many other options, but not applicable to this particular scenario. So it was automatically predicted or identified as binary prediction. Then we move to the next step. See this? Feature engineering. It's already went through all the other variables and identified some of them totally irrelevant. Customer ID, too many distinct values. Ignore it. I don't want to consider this as one of the variables. It makes perfect sense to me. Gender, row correlation with chair. You still can enforce it, by the way. It's up to you. It's your decision. But based on the automated process, is not a good predictor in your case, based on the data that you have. So it was excluded by default. Partner, row correlation. Those ones were selected because they have already correlation with the output. So those can be a good predictor. by default. Can you follow this blindly? Yes. Can you make another choice consciously? It's up to you. But everything will actually impact the accuracy of the model down the road. Yeah.
If you enforce it, how can I ensure that it's taken in when it's predicted?
You have to trust what they do behind you. Trust me, because you will see it later on in the report. Everything will, it's a very transparent report.
Right now it shows as though it's optional.
Yeah, but trust me, but in the report itself, it will give you each one of those variables and the contributing factor as well, like how much or how significant each one of those variables contribute actually to the output, outcome. So let us proceed with the next step, the model name. See, it's also, they care about your time as well. You have enough time to do the training, or do you wanna have some shortcut for just to speed up the process, but you may sacrifice the accuracy and the comprehensive process of going through all the models, also all the algorithms and all the parameters. So just for the sake of this demo, so I just give this to the minimum time. Save and train. See, this is where the magic is happening now. This is where the automated process is happening, and this is just to let you understand what is going on behind the scene. Let us follow the steps here. So assume that we need to predict how much the car, the cost of the car, or the price of the car. So those are the questions that we need to answer. Which features, which algorithms, which parameters. So the features here, we need to identify them. This is what happens in the manual process. Those features, feature engineering, etc. So people will spend some good time here. Then which algorithm? Is it this one or this one or this one or this one? Even after we choose the algorithm, which parameter is this parameter, or a combination of those multiple parameters as well. So in a manual world, the manual data science work, those are all the decisions that the data science need to make. Then they come up with the model, then they see the results of the model with 30% accuracy, based on comparing the result of my model to the base model. That's one iteration. Then they try another one, 50%. It's getting better. And you need to do that multiple times, multiple iterations, and compare those results. Then come up with this best candidate. See, this is exactly what AutoML is doing. It's doing into consideration all the inputs, all the algorithms, all the features, all the algorithms, all the parameters, then they come up with the best performing model. This is exactly how it works. She's getting something here. Just to save time, because we only have 7 minutes left. So just give you an idea. I did that already yesterday, and this is the report that I was talking to you about. So once you train the model, it will give you a very, very comprehensive report that can help you understand exactly how the predictors are impacting actually the output of your data. So here you go. First of all, the model performance is 85. AutoML was not able to find any better model with accuracy better than 85%. If you need to take it to the next level, once you go to data science to do their model and beat that, that's okay, go ahead. But this is what we have so far. Also, in this comprehensive report, you can see actually the top predictors. You have a question, someone asked about the, you have a question about the impact of each one of those predictors. So each one of those, it will tell you how significant each one of those variables is impacting actually the outcome. And if you over it, you will see that the feature name, which is contract month by month, has 0.31, like 31%, followed by internet services, fiber optic, followed by team, followed by whatever. So you have actually like a very visual way to tell you exactly the impact of each predictor in the output. Also, the confusion matrix that Matthias talked about in the before lunch session, for those of you who attended the session, this is the complete confusion matrix here. The model was able to predict 1 of 3 of the cases that were already in the actual, based on the tested data, were actually churn. Predicted churn, actual churn. Predicted stay, this is our model performance. Prediction, here is the performance of the model, here is the actual based on the test data set. Predicted stay, in reality, no, they churn, which is type what? Type 2 error. And this is actually stay and predicted churn. So the model predicted those guys to churn, while in reality, no, they actually stay, which is type 1 error. And the biggest bucket here is when the model predicted stay and the actual stay. This is the majority of them. So this will take us to the explanation of the confusion matrix. You call it confusion matrix because it's a confusion matrix. And so self-explanatory title. So this is actually the prediction of the model between positive or negative, and this is the actual of the data based on the testing data, which is between positive and negative. Those we don't have any problem because the model and the reality, they agree. This is true positive and this is true negative. So we don't have disagreement here. Here is when we have disagreement between what the model predicted and the reality, how it is behaved in reality. And as you see here, the sensitivity, the recall, etc. Actually, the time is passing so quickly. So there is also always trade-off between the type 1 error and the type 2 error. Because which one is more costly to you? Do you want actually to increase the type 1 error and reduce type 2 error? Always trade-off. You have to compromise. You have to make decisions because they are or competing with each other. Do you want to flag customers who actually less prone to churn as a churn because you need to approach them and make sure that they will never leave the company? Or you are actually like, it's okay to let some people go if I don't predict them to churn. What determines this decision is business. Because if you flag them as a churn, but the reality they will stay, you will approach them with promotion or discount that they didn't need actually to stay. They actually were going to stay no matter what you do. So you actually wasted some money. Okay? So you have to take that into consideration. So what determines that? This is actually the threshold here. See, the threshold here, when I make the trade-off between the recall, increase the recall, and increase the decision, type 2 error and type 1 error, the numbers will adjust based on that. Which one is more costly to the organization? Or do you want to actually be less conservative with the customer, and if they actually I don't flag them as a potential churn customer, but if they churn in reality, I don't really care. So which one is more important to you? Is it to retain them? Or because sometimes if you retain a customer that will churn with too much actually cost associated, this is not going to be profitable for you because let them go. So just to jump here, this is actually the beauty of what we have here, is the cost-benefit analysis. And the cost benefit analysis is actually now taken to the business, because the business now they have control over between the cost and the benefit. Which one is most costly to you? Is it the cost of retaining the customer if they don't even intend to retain, or the benefit of actually retaining the customer is higher than the cost? Then by playing with those cost and benefit parameters, which one is much higher? The cost of actually moving the customer or the customer chair or the customer state. Then if we play with those unit and benefit scenario, you actually come up with the optimal point here. So according to this parameter here, the model here, the optimal in this scenario, and even it's explained here, 0.7%. 0.7% as a threshold. So if anything less than 0.7%, don't treat that as a churn. 7%, 70% and above, yes, consider this as a churn, because this is the optimal threshold. Then once you are comfortable with that, you can just proceed now with applying the model and change that to 0.7%. And just save and apply. So I have now deployed model with the threshold that you identified based on the cost benefit scenario planning that you did. And now we can switch it to actually the future data. So if you have any future data with certain condition based on the threshold, it will be flagged as a churn or not churn. Then you can start actually using your model to apply for your data. So the quick here, the summary here between those two approaches, between AutoML and Power BI, again, it requires premium capacity. Yeah. And the other one is in the Azure, it requires actually Azure subscription. I'm sorry, we took longer time. I'm sorry about that, but I will be happy to answer your questions after the session. Thank you.
A huge thanks to all the organizers who made this event possible. So organizers, please get up, and attendees, give them a big round of applause.